Andrea, what is force?
I'm so glad you asked, Chelsea. Force is causing a resting object to move or accelerate a moving object by changing the object's speed or direction.
That's so cool.
Chelsea, what is friction?
That's a good question. Friction is the force that resists the sliding or rolling of an object on top of another. There's 4 main types too. There's static, sliding, rolling, and fluid.
That is so interesting, Chelsea.
This is an example of rolling friction.
Bang, 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 bang. Boom, 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 boom. Bang, 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 bang. I love the way you walk, and I love the way.
All right, now we're going to show you fluid friction / air resistance. You can't push me because I'm static, so I won't move. This is sliding friction.
Suppose you are dragging a heavy equipment crate across a flat wooden floor. The total mass of the crate is 40 kilograms. The coefficient of kinetic friction between the crate and the wooden floor is 0.3. Now, what we're trying to find out is the friction force acting against the crate. This is our first equation. This is going to be our second equation. So our mass is 40 kilograms. So we're going to put that over here. G equals gravity, which is 9.8 meters per second squared. Now, I'm going to set this up and then you guys are going to solve it yourself. Did you guys end up getting 392? If you didn't, you're wrong.
Boom. Roasted.
Newtons. The coefficient of friction is 0.03. So, we're going to write that here. And now we're just write out our equation. Now, it's your turn to try and solve it again. Did you guys get 117.6 newtons? If you did, you're right. But if not, you're wrong again.
Boom. Roasted.
Kid, we gotta break the mold. Truth, trapped in the stronghold, freezing cold. Devil Chad's wrath is a crushing wave. A static force, sealing up the gate. Don't break her out, we need a massive push. No time to stall, no beating around the bush. Newton's first law says he'll stay at rest until our counter force puts his wall to the test. Move fast, accelerate, overcome the friction, change your fate. Our body is bullet, but we defy the floor. Hitting Chad's fortress, smashing through the door. Atomic acceleration, feel the impact flash. Every action has a reaction when we crash. Let's get the rescue down on Easter, sliding down the corridor. Rubber on the top, kinetic friction heating up. Mile after mile, Chad thinks his grip is an unbreakable bond. But Newton's second law goes above and beyond. The more mass he brings, the more force we apply. We're gaining momentum, watch the breaking jabs, gravity, escaping the wrath, escaping the calamity. Friction slowed us down, but momentum pulled us through. The physics of the rescue.
Hey, Olivia, guess what?
What?
Sit down there. Oh.
How dare you do that to me? Okay.
We're supposed to be saving Chelsea.
Did you hear about gravity and weight? Oh my goodness, gravity has such a downward pull towards the center of the earth. It's so annoying. Like, it reminds me so much that weight is equal to mass times acceleration. And you know, weight and mass, they were kind of cute together, but they just didn't work. They were too much alike. You know, opposites attract. That's why weight equals mass times gravity. Like, mass and gravity, those are couple goals. Like,
Aww.
oh my gravity. Newton had 3 laws. The first law is inertia, which basically means that an object in motion will stay in motion. So when you look at a car crash, person who is in the car, they hit, they're not going to stop moving, they're going to continue moving. That's why the airbag there is there for protection.
Miss Emmy,
Yes?
what is the formula for acceleration?
Great question, Carmi. The formula for acceleration is acceleration, or A, equals the net force, so I'm just going to write force, over the mass of an object. Force occurs in pairs, so for every action, there's an equal reaction. And those are Newton's laws.
This is an example of stopping a moving car. First, our example problem, we have a 1,200 kilogram car and it is traveling at 25 meters per second, and that's around 56 miles per hour. And it slams on its brakes and comes to a complete stop in 4 seconds. And what we're going to be finding is the average braking force applied to the car. To solve this problem, we're going to use the base equation, force equals mass times our velocity final subtracted by our velocity initial over our time. Now that we have our equation, we can start plugging in our variables. First, we are looking for a force, so we're going to leave that as unknown. Then our mass, we know, is 1,200 kilograms. For our velocity initial, it's 25 meters per second. And since we came to a complete stop, our velocity final is 0. And our time is 4 seconds. So now we can plug this into the equation. Okay. We'll leave our force as F. Our mass we put in here. Then we put 0 because our car is at a complete stop. Our velocity initial is 25 over 4. Okay, following order operations, we would do 1,200. This would just equal negative 25 over 4. Then we would multiply these two together, which would be negative 30,000 over 4. I want you guys to finish finding the final force. If you did the math right, you should have got an answer of negative 7,500 newtons, since we are in force. If you did it, you're wrong. Our first demonstration of a car crash is you driving off a highway into either sand or snow, going at 40 miles per hour. Your time of impact is around 0.3 seconds.
I can listen to you. It keeps me stable for days in cars.
In that current scenario, you're able to sustain no injuries. And the reason why is that your time of impact is long enough to where the car will actually experience most of the damage, while all of the impact force relieved onto you will be significantly less. Our second example is you driving an old rigid car at 40 miles per hour into a concrete wall, and your time of impact is only your time of impact is only 0.005 seconds long. In that collision, you are bound to die because your time of impact was so short that you instantaneously got all the force hit into you.
To sum up what we've learned today, force equals mass times acceleration, and unbalanced forces is when a bigger mass can push a smaller mass, and then two masses of equal mass, can not push each other, and then a smaller mass can't push a bigger mass.
The next one is friction. When you have friction equals mass times the change of velocity, velocity final minus velocity initial, all over time. And the force of friction is equal to the coefficient of friction times the normal friction force.
Moving on, weight equals mass times acceleration, and gravity equals 9.8 meters per second squared on Earth. Next is Newton's laws. First is inertia, second is acceleration equals net force over mass, and third is every action has an equal reaction.
Coming back to car crashes, a longer time of impact means that the person will experience less damage while the vehicle experiences way more. Vice versa, if you have a very short time of impact, that means your vehicle will experience less damage while you experience the most.
Physics, the fundamental science, explains how the universe works. By discovering the laws of nature, we can see the way the world works more and uncover more technology that can be modern and help us discover the solution to many issues like starvation, global warmings, and other controversial topics I can't really talk about. Physics satisfies human curiosity. You can cut now.
Solve this equation, we're going to use the base equation. Wait, start over. In that scenario, you are able to sustain no... Can we start over?
I'm dead.
Emmy didn't make it to the video because she left us for another crew.
Emmy, that was not slick.
I almost fell. Ultimately, physics is on fire. Go. Physics is human curiosity. I was curious about how this pole worked, so I started climbing on it. Thank you for watching our entertainment, and I hope you enjoyed. Now, for the next 40 seconds, you will watch me eat spaghetti because we did not meet the 15-minute mark.
D.O.G. is my BFF. D.O.G. is my BFF. Clap your hands if you love your dog. Stomp your feet if you love your dog. Clap your hands, stomp your feet, say yahoo if you love your dog. Spin around if you love your dog. Go crazy if you love your dog. Spin around, go crazy, say yahoo if you love your dog. D.O.G. is my BFF. D.O.G. is my BFF. All I wanna do is pet a bear.